Hello students, I am Dr. Yasha Tayal from ABES Engineering College, Ghaziabad. In today's lecture, we'll talk about superconductivity in nanomaterials, which is part of engineering physics from AQ2 syllabus. This particular unit is divided as per AQ2 syllabus in superconductivity and nanomaterials. I have divided my lectures in 6. Very first lecture talks about superconductivity, its basic concepts, temperature dependence of resistivity in superconducting materials, Meissner effect. Lecture 2 talks about temperature dependence of critical field in superconductors, persistent current in superconductors, categories of superconductors which are type 1 and type 2 superconductors. Third lecture talks about high temperature superconductors, which are of huge applications. And we talk about properties and applications of various superconductors in our third lecture. Fourth lecture talks about nanomaterials, which is the second part of superconductivity nanomaterials. In this lecture, we have talked about significance of nanoscale, properties of nanomaterials, which are arised from the nanoscale objects, which are nanoparticles. And again, basic concepts of quantum dot, wire, and well, which are again classification of nanomaterials on the basis of confinement of nanomaterials in 1, 2, or 3 dimensions. Fifth lecture talks about fabrication of nanomaterials. In our syllabus, we have 2 types of fabrications, sol gel and CVD. CVD is an example of top-down approach, while sol gel is an example of bottom-up approach. And then finally, we talk about applications of nanomaterials. Sixth lecture talks about frequently asked numericals in our this particular unit, superconductivity nanomaterial. From this topic, numericals arise from superconductivity part only. And these in this section, we have talked about important numericals which have arisen in the past 2-3 years in both odd and even semester. References which are taken for our lecture are with the help of 2 standard books, S.U. Pillai by Solid State Physics by S.U. Pillai, and Concept of Modern Physics by Arthur Weiser, along with various research links which are being shown here. Thank you so much for patiently watching this lecture.